Alright, so today I'm going to do a quick test prep video. Not too quick, but just go through some normal distribution problems, getting ready for our next test, which is going to be on discrete and continuous probability distributions. Now, with that said, we were supposed to have a test that's coming up Wednesday, face-to-face in class. I announced this last week in class, but I will be out of town this next Wednesday. So I'm going to try to stream on Wednesday night. If you get a chance to be on, we'll talk some more about confidence intervals, which is the next area we're going into that I covered in detail last Wednesday. But this particular video right here is just going to be on continuous distributions. I'll also come back and do a more recent one on binomial distributions or discrete distributions, not just binomial. And we'll go from here. So let me test real quick just to make sure. Yeah, let me adjust some things here. So my sound effects are probably too loud, so I'm going to adjust those down. Because I only really want that in the background. I don't want it to be the foreground music. So I think this is okay. So I think that's okay. I'm going to back it off just a hair more. And I think that'll be okay. As you can see, I'm quite the professional as I bring up my iPhone to test to see whether my sound is okay or not. So, all right, so as you might know, if you've ever attended one of these before, I stream from my 2015 series Mac. I use Ecamm on the Mac. It does bog down my resources a little bit because it's a little older computer, but I love Ecamm. I'm trying to stream a little higher rate today, so we'll see how that goes. Right now it's looking like everything is okay. Nothing choppy, everything shows up all right here. I'll do a backtrack on the video to make sure it does that later. So again, today I'm going to talk about some normal distribution problems. I'm a little blown away because some of the stuff I was going to show you were how to draw these on your TI calculator. And unfortunately, my online TI calculators do not have the exact same compatibility as a regular TI-84. So there are some losses there, and part of those losses are the shade and the graphing when it comes to graphing the normal distribution. I'm sure you can do it. I just hadn't been able to find it. So I don't know where it's at, and it doesn't look exactly like what you're doing. I try not to mirror it with some crazy 14, have to go 14 steps to get to it instead of just getting to it like a normal person would on TI. Okay, so let's move forward. Let's go into our workspace and let's talk about computing probabilities. We have done many of these, but I want to make sure that you have at least something to refer back to so you have an idea what's going to be on the test, types of problems, same ones that we've seen in class already, same ones that have been assigned, but I want to make sure that you feel comfortable when you look at these, you say, oh, I know how to do these are okay. So, as you can see up there on the workspace, in exercises 1 through 6, assume the random variable x is normally distributed with a mean of 174 and a standard deviation of 20. Find the indicated probability. Well, as this stands, we could certainly draw a picture and get an idea. Right? Always a picture, because remember, I want you to walk out of here with an intuitive sense of statistics as well as understanding the formulas, how to go through working through the computations and knowing some vocabulary. But a lot of that will drift over the years, so I want you to really have a problem-solving intuitive sense of how to approach this. So we are looking at change the color there. We're looking at a normally distributed set of data with a mean of 174 and a standard deviation of 20. So if I go one there, then I'm looking at 194. If I go one more that direction, one more standard deviation away, then I'm looking at what, 204, 214. And I'll leave it at that for the time being. If I go down, then I'm going 64, 54. And if I go down another, then I'm looking 44, 34, no problem. So in other words, what I've got here is, that's not good. what I've got here is 0, 1, 2, -1, -2. In other words, how many standard deviations away from the mean are we sitting? What are the z-scores? So in this particular one right here, we're looking, the probability is less than 170. Okay, so the reason I draw the picture is just to go from an intuitive sense. So we've got 154. So 170 is somewhere right here. Somewhere right there is 170, which means we're trying to find the area less than. We're trying to find the area under the curve all the way back to negative infinity, right? Okay, well, you know it's less than 50% because we're less than this 50% mark right here. So you know we're less than the median as far as the area goes, and we're quite a bit less because this little bit right here, believe it or not, there's a lot of area right in between there because of how high it is. So let's backtrack for a second. So we know it's less than 50 intuitively. We know if we came up with an answer larger than that, we'd be wrong. So let's take a look at how we get to the next little bit here. We're going to take we're going to find the z-score for this point 170. What we're looking to transform it to is not the probability that x is less than 170, but the probability that the z-score is less than some score that we come up with by using this transformation formula. So we're going to change the x value. In other words, we're not looking at 170. We're now looking at the z-score, the measure position that represents 170 on the standard normal. So our x value is 170. Subtract 174 divided by 20. Okay, 170. Oops, 170. Subtract 174. Let's be precise. Minus 4 divided by 20. And I get negative 0.2. I don't have my table up here, the table that we used in class to bring up and reference back today. So what I'm going to do now is transition to the calculator, and let's take a look at that. So in other words, instead of looking at this, we're looking at this. Okay, so the probability that z is less than negative 0.2. All right. I still have almost all of that up there. So let me just do this. So we're looking for the probability that the z-score is less than negative 0.2. No problem. So on my calculator, and I should have cleared that out. On my calculator, what I'm going to do is I'm going to go to use the second function of the vars key. I'm going to go to the distributions, DISTR, and I'm going to scroll down until I get to normal CDF, because this is a cumulative density function. And unfortunately, I've written that underneath me. So we're going to normal CDF. That's what we're going to do, okay? So on my calculator, I go second vars. You'll scroll down to the second one, normal CDF. Now, if yours comes up with a wizard, you can use the wizard. I've always stated that. I don't have any issue with the wizard whatsoever. But this is the way that I work it. In other words, I'm going to find the far left z-score, the far right z-score as you're facing that normal distribution, and I want to find the area in between those 2 points. Now, in this case, we're looking for less than 170, so we're going all the way back to negative infinity. Negative infinity is not a number. I just need to find a number far enough out there that I'm not going to have any errors in decimal places as to what my answer is. So what I'm going to use here and what we use in class is negative 10. You can use negative 5 and still be okay. We're going to use negative 10. So from the far left to the negative infinity, I'm just going to go negative 10 and then comma, and then my far right point, my largest point, is negative 0.2. The z-score that we came up with when we did our transformation. So I get 0.4207. Okay, no problem. And that's less than 50%. We're looking, oops, my apologies. I forget that in this screen I am a little less than normal, so we get 0.4207. There we go. Okay, so there's the answer to this particular problem right here. What is the probability of x is less than 170, given that we have a mean of 174 and a standard deviation of 20, which of course you can't see right this second, but we were looking at a minute ago. It's 0.4207, okay? All right. So let me erase this off. Let's go to the next one. I'm just going to stay on this screen right here. So we are going to go to this one now. And what we're looking for here, we're not going to work with the probability that x is less than 200. We're going to work with the probability that some z-score is less than the equivalent to 200 within this particular normal distribution, where the mean is 174, standard deviation is 20. So the first thing I'm going to do is transform it. My x value here is 200. I'm going to subtract the mean, which is 174 up there at the top. And what you can't see up here at the top is that the standard deviation is 20. I had it on my screen a second ago. And so I've got 200 minus 174 divided by 20. Gives you 1.3. So 1.3 is my z-score that corresponds to the 200 in this given normal distribution. Okay, no problem. So I'm going to put this, because what we're working with now is not that the probability of x is less than 200. We're working with its equivalent that we can actually work with. The probability that z is less than 1.3. Well, again, we're going less than, so we're going all the way out to negative infinity. Okay, so we're not going to use negative infinity. If we go out to negative 10, we're going to be far enough out that this will give us the same probability out to 4 or 5 decimal places that we know errors. So I'm going to hit clear, second, vars. The second didn't take. Second, vars, there we go. Normal CDF. And this is what it should look like on your screen. We're only working with 2 numbers here. I try to keep it simple. The area between this z-score on the left-hand side of this normal as you're looking at it, and the z-score on the right-hand side, the far right-hand. In this case, once again, we're going to go negative 10, comma, and we got 1.3. That was the equivalent of 200 from our standard distribution that was given. So 903, we'll just go 0.903. That's good enough. Equals 0.903. There you go. So about 90% of the curve lies between 1.3 and negative 10, or all the way to negative infinity, really. Okay, not sure if anybody's in the stream. I didn't really announce this one. I'm just going to post it to the Moodle, so my folks will have an idea of some of the types of problems they'll see on their test. So now let's move on to the next one. Now we're looking at a little bit different scenario. Not much, but let me scratch this out. We're not working with that. We're not working with that. We're done with it. We are going to work with this one. So the probability that x is greater than 182. So pictorially, we have a normal distribution with a mean of 174, standard deviation of 20, 84, 94. So if you're looking at standard deviations away from the mean, one standard deviation away from the mean is 194, which tells me with the 182 that we're sitting somewhere like that. Okay, so we're looking for the area here from whatever this z-score is all the way to infinity. So terrible that I run out of room because of the way I've set this up. But anyway, we're going all the way out to infinity. Well, we can't work with the 182 the way we're working these now. And what we did in class was we just transformed these from a data point on the normal distribution to a z-score. In other words, a measure position of how far that number 182 is from the mean of 174. Okay, that's just going to be a distance measure position. So I'm going to erase this off. That's just our common sense intuitive view. And now let's do some crunching. So I want this to be the probability that some z-score is greater than whatever the transformation becomes from 182 to the z-score. And we go z-score, and that is equal to the x value, 182, subtract 174, divided by 20. Okay. So 182 divided by, how easy it is to make a mistake. Subtract 174 divided by 20. And to be exact, we are at 0.4. So this up here is equal to 0.4. That is our z-score. So when you're looking at the data from that distribution or from that set, 182 is equivalent to 0.4. It is 0.4 standard deviations away from the mean of 174. Okay. So I'm starting to lose my voice a little bit, sorry. And write 0.4. Okay, we are not going less than. So we're not going that minus 10 up to 0.4 this time. We're going greater than. So remember from the picture I drew a second ago, we're going from our leftmost point of 0.4 all the way up to infinity. But in my class, I just ask you to use 10. 10 is going to remain constant across. You're not going to have a 5 decimal. You're not going to have a huge issue with what you put on your assessment or what you're putting down as a presentation to CEOs wherever you work when you're talking about their data. So what this looks like is, I'm going to go clear. I'm going to go second, vars, normal CDF. And now my leftmost point is this 0.4. And I'm going to go all the way out to 10. I don't even have to hit enter on this particular calculator, but if I do, there I've got it. 3.446, let's say. 0.3446. So about 34% of the area underneath that curve lies between 0.4, standard deviation of 0.4 all the way out to infinity. About 35% right in there. Okay. All right. No questions. Nobody's posted anything, which is great, although there we go. There's a few folks on. I'm not sure where they're at. Or there were anyway. People probably just popping on saying, what the heck is this? And then they don't stay. This is okay. All right. So there's that one. Let's move on. And I'm going to push on down to the other one. We've done less than 2 of them. We've done a greater than. I'm going to double line this, and I'm just going to skip that one. We're going to go to number 5. So we want to find the probability that any x value in this distribution will lie between 160 and 170. So what's the probability? Well, the probability in a normal distribution is the area between those 2 points. We're going to work with the area between the 2 z-scores. So what I have to do, find the z-score that corresponds to 160, which is z equals 160, subtract 174, which was the given mean, all divided by 20, which not showing up at the top because the way I've crunched my screen in, the standard deviation was 20. So the z-score for that is going to be 160 minus 174 divided by 20 equals negative 0.7. So there's one z-score that we were looking for. You can barely see it on the screen there. Now I'm going to get the other one right here. Z is equal to 170. Subtract 174 divided by 20. I think we did this. Oh, we did this with the first one, yeah. So 170 subtract 174 equals divided by 20, negative 0.2. Negative 0.2. There are the 2 z-scores. So we're finding the area between 160 and 170 on the data curve. We don't have a whole lot to work with most times unless we have done a transformation with it. Then we can look at our table, or unless we're working with syntax on the calculator, which we can use this for syntax. But what I do in class is I just break it down to the very easiest way to look at it, which is between a z-score and a z-score, in my opinion. So we're going between these 2, so it's going to look like it's going to look like this. What is the probability and my z-score falls between negative 0.7 and negative 0.2. I barely got it on there. We're good. Okay, so to the calculator I go. Second, vars. And again, in class, we had a table that we did a lot of work with. I actually liked the table a lot. And typically, I have found that when my students got used to the table, they would go to the table as an easier way of doing it than remembering syntax on a calculator. But all we have to do is go to normal CDF, normal cumulative density function. And I am going from negative 0.7, comma, to negative 0.2. And if that makes sense for both of those numbers, yeah, they were both less than 174, which was the mean. And I've got about 18%, so 0.1788. So the area underneath the curve, which will always be a positive, you're not going to have a negative area underneath the curve. Let me push this out because my big head's in the way. So that particular one, you're going to have 0.1788. So about 18% of your area underneath the curve falls between 160 and 170 when you're looking at it with data, and falls between a negative 0.7 and negative 0.2 when you're looking at it as a transformation into z-scores. Okay. Hopefully this makes sense to you. No questions? I don't think anybody's on from my class. I don't think anybody's on at all. No, earlier there were 2 or 3. They've dropped off. Okay, so let me clear my screen here. I'm going to back out of it anyway, so I'm going to back out of my Doceri for just a moment. And let's look at some problems that are the same, but just set up a little bit different. Let's go here. Zoom to fit, maybe. There we go. Okay. Zoom to fit. Just going to look at a couple of these. These look very similar to what I just had, don't they? So I just want to glance at these real quick. The difference in these and the ones we were given is that, let me switch here, is that these particular ones, like let's look at 51 here. 51 is talking about the probability that the z-score is less than 140. The z-score is less than 1.45. What we had before was that the probability was that x was less than 70. I don't know what, there's no numeric transformation from to here, so I don't know what the exact numbers are. And we took that 70, made it, transformed it into a z-score, and then we were looking at the probability that z was less than 145. So in this case, in this particular case, let me erase this off before somebody's going to ask a question. Where'd 70 come from? Arbitrary. We don't have any numbers to go with this. But if we're looking at the probability that z is less than 1.45, then we go straight to here. Second, vars, normal CDF. And it's less than, so we're going all the way to negative infinity. So you've got negative 10, comma, 1.45. About 93%, so 9265. 0.9265. So you see, you could have problems that are already transformed into the z-score. You might be given problems that have data, where you're talking about x values, then you're going to have to transform them to a z-score. These problems right here are nothing more than what we just did, other than they are already in terms of the z. Okay, so let me close out of here real quick, and let's get to the third piece here. Lost my mouse. Give me a second. Dude, I've completely lost my mouse. There it is. Okay. So I'm going to go to preview. I'm going to open this up. Actually, I'm going to pull this down. I'm going to insert third set of problems. Bring this up. And if I go view, we'll zoom out. Okay, I can work with this. Heights of men, heights of women. We'll just work with heights of men right now. There we go. Okay, now you're looking at problems that have context to them, right? You're looking at problems that have some kind of backdrop. This first one, heights of men. A survey was conducted to measure the heights of U.S. men. In the survey, respondents were grouped by age. In the 20 to 29 age group, the heights were normally distributed, very important, with a mean of 69.9, also very important, and a standard deviation of 3 inches. A study participant is randomly selected. So you reach into the pool, you pull one person out. What's the probability that this person's height, that his height is less than 66 inches? Okay. Do I have enough room? I'll go below. Okay. So in this first one right here, find the probability that the one study participant that was randomly selected has a height that's less than 66 inches. Okay. So the probability that his height is less than 66 inches is equal to the probability of some z-score being less than whatever we transform that to. Okay? So we're going to transform it as follows, just like we did before. I'll put it up here. The z-score is equal to x, subtract the mean divided by the standard deviation. The x value we're looking at is 66. Subtract the mean, which was 69.9, divided by 3. Okay. 66 subtract 69.9 equals, divided by 3 equals negative 1.3. Okay. So what we're looking at down here is what I say it was, negative 1.3. So there we go. So now this is what we're working with. The probability that z is less than negative 1.3, which is equivalent to the probability that the x value is less than 66, or the probability that one selectee has a height that's less than 66 inches. All right, so let's go second vars, normal CDF, and we're going less than, so we're going to go all the way to negative infinity, which in the case of my class, I just have folks take it out to negative 10. It's easy to remember. Takes it out far enough where there's no discrepancy with the decimals, and then we're going negative 1.3. It's going to be less than 50 for sure, and it is 0.096, 0.097, let's just go with. So it equals 0.097. There's your answer. And we do this with all of them. It's the same, but you have to understand that the problem is telling you that it's normally distributed, and they're giving you an X value. In other words, we reach into the pool of applicants, the pool of population. We pull out one male in the case of heights of men. If we were doing heights of women, it would be one female. We randomly select one female out. What's the probability that their height is less than some inch value? Heights of men, in this case, we were looking at that the height is less than 66 inches. We transformed it. We worked with the z value using the calculator. There's our answer. Much of the same, actually, for all of these. These have context. The second set were just x's, and the first set that I gave you were x's as well. Okay. I think that's all that I had. I really was going to work with, and I don't have my calculator to do it, but I really was going to work with this right here. This is what we just worked with, right? Steps for calculating cumulative probabilities for a normal distribution are as follows. So here's what we just worked with. So I will work from this for just a second because I want to see how this shows up on the stream. And I've just got the syntax right up above so you can follow along, write that down if you need to. It's just in my verbiage. So if you find a better way, if you go online and find an 80-minute video that talks about this in more detail and you like that better, fine. If you find it written somewhere, no problem. Just my verbiage. So I'm going to clear that out. So the trouble is I got no place to write, but it's okay. So health club schedule. The times per workout an athlete uses a stair climber are normally distributed with a mean of 20 minutes and a standard deviation of 5 minutes. An athlete is randomly selected. Find the probability that the athlete uses a stair climber for less than 17 minutes. So we're going from negative infinity to 17. In z-score wise, we're going from negative 10 to whatever 17 transforms to as a z-score. Okay, so verbally keep that in mind. You should be able to follow along with this. Okay, so I've got my x value, subtract the mean, which was 20, equals, divided by 5. So we're going from negative 10 to negative 0.6. So 7 vars. Negative 10, which is the value that we chose in my class, what I chose, I like to use, to negative 0.6. So there's the probability. So about 27%. So the probability that the athlete uses a stair climber for less than 17 minutes is 27%. If you've ever used a stair climber, 17 minutes would be a long time on there. Good for whoever's doing that. Just say it. Okay. So there we go. I've gone through a few problems with normal distributions. I will come back maybe tonight, but I don't think so because it's already 4:44. So I don't think it'll be tonight, but maybe if not tonight, then tomorrow I'll do a couple of binomial distributions. These are all to get you ready for the test that was going to be this next Wednesday, but is going to be pushed out to the next Wednesday because I will be out of town this next Wednesday for our face-to-face meeting. So I'm going to do a stream on Wednesday night. It'll probably be through Restream. It won't be as set up as this. It'll just be me talking through any questions you might have. And I may or may not have my Apple Pencil and my Doceri set up because I'll be just with my laptop or iPad. So that's all. So as always, I appreciate anybody that came by and watched this. I really do appreciate you coming by. I ask that if you haven't subscribed to the YouTube channel, please help me out and just subscribe. I'm not a monetary streamer. This just makes me feel good on the inside that somebody subscribed to my channel and likes a little bit of the content that comes out of it. And again, these are my online office hours videos, lives for my face-to-face students in my statistics courses. All right. I appreciate you stopping by and thanks for being here.